All right, it says it's recording. So let's see. Resume. Huh. It says zero. All right, so let's begin.
We voted to change it on the day when we voted. They only used it because I voted. We had right. Yeah. How many more? They already.
Okay, all right, class, let's go for it here. Can you guys solve this for me? Should be easy. Like, oh, Mr. Review, that's pretty easy. Possibly. Try really, 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 really hard.
You give us the first step.
Stalled for you. So x squared minus 7x plus 12. Isn't that factorable? Is that right?
Yes.
Notice whenever we factor stuff out, craziest thing happens here. This is what, x minus 3x minus 4?
Yeah.
Everybody agreed there? Notice whenever we get our answers. So if we set each of these guys equal to 0, and from here we can pretty much say, what are my answers? 3 and 4. Okay. So notice if you go all the way back up here, notice what happens here is that little 12. Aren't the answers just factors of 12?
Yes, they are.
Right? Technically. So it leads us to something called the rational roots theorem. It's not in the book. Why don't
Should we write it down?
This one we should write down. Huh? No, sorry. So real quick here, let's go with something called the rational.
Oh wait, the person who invents
do not invoke that. Do not.
Go.
Just want to give you an example here. So whenever we solve stuff, the factors of the, in fact, the end and the beginning tend to be our answers if they are fractions. So let's go with rational root theorem. This is the only new stuff here. The rest of it we're going to put it together. Remember long division?
Yeah.
Remember synthetic division? We're going to finally kind of use it all together.
No.
Finally, it all comes together. So just, this is not so much an exercise for the section, is just to recognize this right here. It's just the fact that whenever we get answers, our fraction answers and whole number answers are always just factors of our in stuff.
Are we ever going to do long division with 5?
We could.
No.
Yeah, because it's a linear answer already, so that we need to.
Wait, long division with what?
Okay, we good? Yeah. Yeah, I got rational.
Wow, that's so
Roots.
fun.
Figure out.
We can think where.
All right, so let's go with it. If I have a function, and I'm gonna put a. But this is gonna look kind of weird, but we're gonna try it here. So I'm gonna say a to the n, x to the n, plus. This is how we write a polynomial that's like huge. It goes on for like ever and ever. We go like this. This could be to the 4th power, to the 7th power, to the 28th power, whatever it is, right? So again, what's the again? Yes, it was. Yeah, I didn't. Did I refer to it or no? No. Just- Sorry. I just want to say what the rational root theorem is. So this guy is called a polynomial function. This is the way we generically write a polynomial function. So f of x is all this right here. And we say the real or no, the real, sorry. Real. It's a to the n, and it's x to the n. Then it's a to the n minus 1.
Yeah, on the end, is that
That's 2 x to the 1x. Good morning, Jaden.
His hands live. Yeah,
His arm is back. Awesome. Feels good to have that.
Wait,
Oh, really? Ouch.
hey, his left hand is. It's good. What? He has an arm. He has an arm. It's not like it is awesome.
A0, yeah. Case of. I'm gonna say it.
I just did something. Did you get it? Is that the rational? Really loud in here. Yeah, I think so.
Jaden made everything. Everybody's happy to see you. That's it. All right, class, let's see. So we're going to do an example here just a second here, but it says the rational solutions are, and it says factors of a divided by factors of a sub n. So this guy's a sub 0 or a sub o. It just means a constant at the end. So we'll do some examples just a second. I just want you guys to write down the theorem. Jaden does not need to write down the theorem. We'll just go on example number 2. So the whole point of this is to be able to solve polynomial equations. That's it. That's what we've done this for. Yeah.
That's over 0 or what?
It's factor of a what and factor.
Oh yeah. So this guy here is a0. It just means that it's the constant in one. It does not have the x
Yeah,
next
but
to
on
it.
the division, that what is the.
Factors of a sub 0 and factors of a sub n. So it is this guy here and this guy here. And what we do normally in mathematics, we just write as P over Q. I wonder if your book is your book. Good. We are doing the video right now. Somebody is good.
So I might just need to accept this, but.
No. But you should be able to learn how to do these problems next year. So tell them if we're ready to go on.
Funny.
Ask questions you don't want the answer.
Okay, we good? So here it is.
I kind of like because we're getting all of our stuff done. We still have our.
All right, class, let's go with it here. We got x to the fourth polynomial. We're gonna try to find all the zeros.
Hey, our teacher is talking, y'all. Come on.
We're good. P over Q. So here it is. What we need to do is we need to figure out P is going to be all the ways I can get a 6. Daniel. All the ways we can get a 6. So I guess we can do this here. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Tell me if you guys agree. So I need all the factors of this guy here. Q is going to be all the factors of the number in front, right over here. So the number in front of x to the fourth is just a 1, is that right?
Yeah.
So here's what the rational root theorem says. If this guy has an answer, and it's a rational answer, which is fractions or whole numbers, right? It's going to be any one of these numbers right here. So it's the ratio of all the different possibilities of P and Q, or P divided by Q.
Well, I'm wondering, what is tail A0? Like, what is that?
A0 is this guy right over here. It's the last number without the X. So notice that Q is only a 1, right? 1 or plus or minus 1. So if I were to divide all of these guys by plus or minus 1, they'd just be the same exact values. Is that right? So here's what we got. We got this guy. We'll do let me do like 3 problems, and I think it'll all fit together. Let's do 3 problems together, and after that, it's going to hopefully make sense here. So because Q is only a 1, if I divide each of these guys by plus or minus 1, my P over Q ratios are all the same. Are we good? Okay, so the whole race here is to find the zeros. That's it. And it's what we do. It is important because when we find zeros, we find solutions. And in fact, when we say solutions, zeros, or roots, those all mean the exact same thing. Yeah, because whenever you multiply to get a -6, it could be a -1 and +6, could be a negative or +1 and -6. All switch around. Okay, here's our little thing. Guys, right here, these are our possible answers. We don't know which one is the real answer, but our possible answers are right here.
Oh, so these are possible.
Yes, so we can test them 2 different ways. You guys tell me as a class, we'll just test them. You guys just want to plug in the values into the equation, into the function? Or do you guys want to do synthetic division?
Plug value.
Synthetic division.
Okay. So here's what I got here. 1, 2, we got how many tables we got? Okay. So I'm going to go with table number 1. We good? I need you guys to test whether +1 is a solution. Table 2, test -1. Table 3. Actually, I should do it first here. Let me do. Table 3, you guys going to test +2. You guys test -2. And table 5, you guys test +3. We good? Calvin, you get -3. Yeah.
How did you confirm that? Or plus or minus?
It is all the different ways I can get +1. Right here. -3.
So we chose +1 or plus or minus 1, but yes, that's what this is.
Let's do 3 examples. Once we get 3 examples done, I think it all should fit together. So just bear with me just for a little bit. Okay. Yeah.
I'm still confused on how to do this.
Well, give me space for 3 examples. After 3 examples, we'll know how to do this so easy. Good.
Light work.
So I'll help out Calvin though. So Calvin and I are going to figure out whether -3 is a solution. And so -3 on the outside, and I could just do this right here. 1, -1, 1, -3, -6.
Yeah.
You can plug it into the equation as well. Jill, I see you. Just 1 second here. And all yours. Go ahead. Yeah, but by the time you multiply all 4 of them out, it may not be a solution, right? Because it's x to the 4th, it's not x squared. So Calvin and I are testing whether -3 is a solution. Here it is. The day on the giggles today. Calvin, doing good there? Oh, true. Thank you. What? I made a mistake? Not on purpose? Okay, did you guys find the answer? Okay, cool. Oh, cool, okay. Table 1, what did you guys get for the remaining? Okay, so class real quick here, we can settle down. If you get 0, you found the solution. If you did not get a 0, it's not the solution. So you can kind of tell, is this kind of going to get to 0, you think, or no? I can kind of stop as I'm going, because like, no, -3 is not going to work. Remainder is group 1, -8. Table 2, remainder is 0. You guys got 0 for the answer? Awesome. Okay. Table 3, what'd you guys get? 0. Okay. For sure answer? Because they're not for sure. Say again?
Oh,
108? Oh, 28. Okay, 28. Hard to hear. Okay, so I'm gonna go with table 3. They found that 2 is an answer. So let's do this one together here. 2. 1, -1, 1, -3, -6. I'm gonna do it real quick here. For those of you that did not get 2, let's do it together here. Just to confirm, because we need something over here. So 1 comes down, 1 times 2 is 2. That becomes a +1. That becomes a 2. That becomes a 3. That becomes a 6. That becomes a 3. That becomes a 6. And that becomes a 0. Awesome. So off to the side, we know that 2 is an answer. Let's keep on going. Let's keep on going. Now that we have that, what's the polynomial that's left over? So isn't this the constant term? Is that right? Here's my leftover polynomial. Yep.
The 2, because I see like the plus or minus 6.
We got it right there.
No, not that type of thing. What are you guys? Oh.
Right, because these are all possible answers, right?
Yeah.
So we tested 1, we tested -1, that didn't work. We tested 2, and it did work. It gave us a 0. So there's my 2. And then because these guys have possible answers, some may work, some may not. Okay, good there, Esther? Talk to me. Okay.
Okay, what did you say?
This little guy right here. So now we are down to this guy. Is it lasso? It's going to lasso it. We'll see. Let's see. Oh, it does. Okay. Just waiting. Oh, that's right. I got to deal with this. Okay. You guys, class, talk to me here. Are we good now? We got it down to this now. So now P is going to be plus or minus 1, plus or minus 3.
Oh, yeah. I mean, if you go down, like.
It's the same problem that we've got down to X to the third finally.
Down. Oh, we just do it with we just do it with we took away the X to the power of 4. That's all we did.
Uh-huh.
Okay.
Come.
Yeah, the.
One second.
Oh,
Hey, class, if we could settle down just for a bit here.
I understand how you
Good.
go the plus minus 1, plus minus 3, plus minus 6. I don't, where did plus or minus 2?
The 2. Yeah, okay, gotcha. So this little guy right here, all the factors of 6. All the factors of 6 are 1, 2. Gotcha. Okay. So let's see what we've done so far, just so it makes sense. So here's our polynomial. We're trying to find zeros, right? We're trying to find technically this. We got our possibilities. We got our possibilities, and we got to here. We did the what did we do? We did synthetic division, and we have this leftover polynomial. So we got this is an answer. We're just looking for more answers, and the process starts all over again. So here it is. We go x cubed plus x squared plus 3x plus 3. All the different ways I can get a 3 right here. All the different ways to get a 1 is right there. And we start over again. So let's see.
So wait, what is Q again?
What is Q? Q is all the factors of the number in front. All the factors of the number right here. So, table 2. Can you guys try -1 again?
You said?
Once again?
Factors of all the number, factor of the number in the very front.
Yeah. There it is. There's your arrows. Uh-huh.
I love
it.
Because we only have a 1. So 1 times 1 is 1, -1 times -1 is 1.
How do we get the plus 3x plus 3? Instead of the minus 3x minus 3. Is this a new problem?
Same problem. We just from our synthetic division, we made it simpler.
Okay. So is there only going to be 1 0? Or what if we have 2 zeros? Then what synthetic division do we do?
We'll get it.
That's 130.
All right, class, let's go with it here. Table 2, Weston Eli Jail. Can you guys do -1 again? Is it a 0?
Yeah.
Thank you. So 1 comes down, that's a -1, that's a 0. That's a 0, that's a 3, that's a -3, that's a 0. Okay, write down the polynomial that's left over.
Yeah, okay. I get it, but I'm amazing now. I would this fight.
All right, class, we good? We're left with x squared plus 3. We know that -1 is also an answer. And now the question is, once you get down to x squared, we have some choices here. We can either do factoring, we can do quadratic formula, or if you just have an x squared by itself and the constant by itself, do you guys remember this little guy here? All we do is we set equal to 0. We subtract 3 from both sides. Oh, this is going to be an I value. Check this out. And if we do a square root,
Everything comes full circle.
plus or minus. Let's see what are our other answers here. See, I think our other answer is plus or minus, right? Or we could do plus. Let's see. We could do a I root 3. Everybody good there? And we have a negative I root 3. Tell me if that makes sense. So we just found all the zeros of this polynomial, all the solutions. List them in order if you need to here at the end. So what do we get as those ones? And then we had ourselves, what's the first one that we found? 2 or negative 2? 2. Okay, so there it is. There's 1, 2, 3, 4. Notice when we did, we started off with the x to the 4th polynomial. So when we get to that point, we know we found all of them. There are no others at this point. Okay, we're good there. Okay, let's do one more. Now we're gonna solve some other fractions here. Okay, you guys good there? This is B, right? B. This one right here.
Wait, sorry.
So.
All right, that's fine.
All right, I'm gonna put a 2 in front now, just so we can actually work this out. 2x to the 3rd plus 3x squared minus 8x plus 3. All right, cool. Let's go with it here. And I got P. Tell me all the factors of P. Oh, ouch. Okay, here we go. Plus or minus 1, plus or minus 3. That is it. That is all the different ways I can make a 3.
So do we not do anything else with the other numbers?
Nope.
For the possible answers? No?
Not for P. P is all the stuff that makes the constant. Let's go. Q. Q is all the stuff that make this guy here in front. So it's always back and front. So anybody with Q? Plus or minus 1, plus or minus 2. So now I got to figure out all the different possibilities I can have of P divided by Q. So if I just use 1, if 1 is it right here, 1 goes underneath here and underneath here, don't I have the same thing? There. Next is, what happens if Q is 2? Now I got to think about Q being 2. 2 goes into here, and 2 goes into there. So I got myself, what, a negative positive 1/2 this time?
Yeah.
And positive negative 3/2. 1, 2, 3, 4, 5, 6. Are we good there? There's my possibilities. So this guy, if it does have rational answers, whole numbers or fractions here, it's one of those 4 possibilities. We got to test them.
It's always going to be one of those 4, not multiple.
It's going to be one of those 8 right over here.
It's not going to be. It's not going to be multiple.
Yeah, it could be that it's not any of those,
Okay.
but if they are rational, there's like, it can be 4. 4 can be an answer here, right?
It just can't be like +1 and negative 3.
It can be low.
Okay, so let's go with, so Keith, and say again, it can be what?
It can't be like two of those 8 numbers. It can only be 1, right?
Oh, gotcha, no, it could be 2. Like the last problem, we found that 2 was an answer and negative 1 is an answer.
Okay. So
So we
then,
did fine.
if we do synthetic division on those, how do we choose which one?
We guess and we just go for it.
Okay.
I'm gonna do, let's see, table number 1. Gonna have you guys do number 1. You guys get negative 1 again. You guys get 3, negative 3, and you guys positive 1/2. Positive 1/2. And Calvin, let's join this group here as well.
This one?
Yeah, positive 1/2, because we have fractions on our hands. 2, 3, negative 8, 3. So 2, 3, negative 8, 3.
Yeah, 60.
And we're gonna do one more problem after this here. So if we do 1/2, let's see, the 2 comes down, half of 2. Table number 5.
It's 54 plus 27 minus 54 plus 26.
Jaden, half of 2. Positive one. Uno. 4, half of 4. 2. -8 plus, thank you, half of that. Oh, bummer. It gives us 6. So I found out 1/2 does not work. Anybody else?
3 is 60.
So again,
Positive 3 is 60.
positive 3 is 60. Okay, that does not work. Oh, you got 0. For positive 1? Cool. Okay. Class, let's go with 1. Group table and 1 got 1. How about table 2? -1?
Yeah, we got 12.
12. And table 4, did you guys get? 6. Okay. Does not work. Let's go with this one. Table 1 got 1 to be correct. 2, 3, -8. 3. So that's 2. That's 2. That's 5. That's 5. That's -3. That's -3. And that's 0. Perfect. Polynomial that's left over. So now we have x equals 1. That's for sure we know. Polynomial left over.
We did it on the previous slide.
Oh, no, it does not. It gave us a 6. So I'm gonna have myself 2x squared plus 5x minus 3. Tell me if you guys agree here. Is that the polynomial that's left over?
Yeah.
Class, real quick here. We have one more problem to do beyond this one. Once you're down to x squared, what else do we have as far as tools? What can we do on this one? We can factor. We can do quadratic formula. Is that right? So which one of these guys do you want to do on this one? Factor or quadratic formula? Tony's going to factor. Weston's going to do quadratic formula. I'm going to do quadratic formula real quick here. So let's do this one together. Let's see if we can do one more here. -5 in here. The square root of 25 minus 4 times 2 times -3.
Find the square of that.
Good. Ben can show us how to find the square of that.
Oh.
Let's go, Ben.
That now? Gotta be on.
Let's see. 2 times 3 is 6. That's 24. Negative is a positive. So 24 plus 25.
Yeah.
49 squared of 49 is 7. Thank you. Over 4. So now we have ourselves -5 plus. Oh, we were so close. -5.
Either way you go.
-5 plus 7 is
2/4.
so 1/2 should have worked. Let's see. -5 minus 3.
-3. -5 minus 3.
Oh, sorry. -5 minus 7. There you go.
Oh,
Sorry.
-12.
12.
Yeah.
7 after multiplying. -4 times.
Oh, sure. Because this becomes
That's why.
good. Table 5. We got a 6 for our answer. Is that true? Look at this, because for some reason it says 1/2 is the answer.
Yes.
Why is that? I don't know. We should have got a 0. Because we
Do you definitely not know, or are you trying to allow us to learn?
help us to learn.
It has to be a minus, it can't be a plus, so this doesn't.
I don't know, what's -8 plus 2? In real. Oh, -6. So that would have been like this, and would we've got a zero? Absolutely, we would have got a zero.
Solve this whole class and I'll do it.
What?
Solve the whole class.
No, you're that one. You solve yours, you incorporate the B in that one. Wow.
That isn't.
What does that even mean?
You have one.
Solve the whole class.
It's a zero of the equation. I like the separation to drop.
It should have been a solution, right? We got one half right over here. Okay, you guys talk to me. One more or no?
Wait, so the answers are x equals 1, 1/2, -3.
This one, so you can just.
So this one, yep, x equals 1, x equals 1/2, and x equals -3. There's my answers.
Yeah, you can see the V and then the A.
Good there, Joe, good. Can't have more because we're x to the third power. And since we're x to the third power, there's going to be 3 answers. Like, because the degree is 3. Hey class, real quick here. I'm gonna modify the homework here. What we're gonna do.
I'm sorry,
Lindsay?
the homework for what?
Keith and Lindsay, real quick here. Modify the homework. We're only gonna do whatever questions are there from 55 to 71. I'm not sure which ones they are, but only do, I think it's 55. I have circled here, but I'm sure 55, 59, 63, 65, 69, 71 only. We good? There's some numbers in front. You don't need to do the numbers in front, just vocabulary, concepts, and then the homework questions that are in this range. We good?
What's the domain?
We finished up 2.5 because I modified the homework for that.
So that.
Are you gonna stop an email?
Sure, I could do that.
How many times have we had to change the?
Just so we get through chapter 2. That's what I'm saying. Just the homework questions inside your homework from the range of 55 to 71. So it's not all of them. It's like
That's all your.
for 2.5, yes.